Good morning, everyone, and thanks so much for joining us for the latest edition of the Shoonya webinar series, where we dive into the ideas and innovations driving India's shift to zero pollution mobility. Today's session is a special one as it marks our 4 years of the Shoonya campaign. And what started as a bold idea has now become a national movement for clean electric transport across the country. And it's only fitting that we're focusing today's session on one of the most important and exciting areas of this transition, which is battery circularity. As EV adoption grows and energy storage scales, we can't keep relying on the linear model that's currently in use, which is manufacture, use, and discard. We need systems that lets us reuse, repurpose, and recycle, and fast. So we've got a fantastic panel today with us, with experts from across the value chain, from the whole battery value chain. But before we get into that, my colleague Akshat and I will just take a few minutes to set the stage, starting with a quick look at what Shoonya has been up to lately. Tanishka, if you could have the next slide. Perfect. So Shoonya campaign, as some of you may already know, was launched by Niti Aayog in collaboration with RMI in September of 2021 to promote zero pollution delivery and ride hailing in India, as these sectors were seen as low-hanging fruits for electrification due to their high vehicle usage, high demand, high daily vehicle usage, but also their centralized fleet operations. So the vision of the campaign included building awareness and demand around zero pollution rides and deliveries, recognizing and promoting industry efforts, and all the while developing a pathway to 100% electrification within these sectors. The campaign is built around 3 pillars. One's corporate engagement, resource toolkits, and consumer awareness. On corporate engagement, we've already have over 230 partners. These include delivery platform, fleet operators, charging infrastructure providers, financiers, OEMs, all working together to scale zero emission mobility. On resource toolkits, we have launched 3 publicly available tools: a finance toolkit to explore EV lending options, and an EV calculator to compare costs and emissions for consumers, a policy map that breaks down national and state level EV policies and subsidies. On consumer awareness, through our collaboration with MyGov, we now have access to over 25 million citizens and have directly engaged over 2.5 lakhs through several campaigns. Our brand films have garnered over 70 million views, sparking mass awareness on zero pollution transport. And most recently, our Shoonya Pathshala initiative engaged thousands of students across over 20 Kendra Vidyalayas in Delhi. We're also expanding this effort to a network of 12 lakh KV students through curated awareness and training materials around electric mobility. Together, these 3 components, and backed by our partner network, of course, have enabled over 900 million rides and deliveries, zero pollution rides and deliveries, and resulting in over 1,000 crores in fuel savings. With that, I'd like to now hand it over to my colleague Akshat to share a bit more about today's topic.
Thanks so much, Vaibhav, and good morning, everyone. Super excited to share our analysis on the battery opportunity in India. And like Vaibhav has very eloquently put into the context, this is focused on the EV battery opportunity specifically, and we'll see why in just a little bit. But the primary reason for that is that it provides the largest feedstock of batteries in the circularity landscape. And the opportunity that we see in and of itself for battery circularity is around 75,000 crores. That's just sort of the revenue and profitability opportunity, but there's also the opportunity to avoid 2.9 million tons of CO2 and create over 100,000 direct green jobs, just if we institute a circularity focused ecosystem. And what fuels this opportunity is that battery demand itself is going to grow around 40-fold from where we are now to where we will be in 2050. And domestic recycling infrastructure catering to that demand can supply over 40% of India's lithium, nickel, and cobalt requirements, which can reduce exposure to volatile import markets. There are a few enablers that we'll need to fuel this growth. First and foremost of which is policy to support second life market development, traceability standards to certify and build confidence, key financing mechanisms alongside technology and workforce development as well. And we'll talk more about all of them in brief as we go ahead in this presentation. Tanishka, if we can move on to the next slide. So what do we mean when we actually talk about circularity, right? It's primarily moving away from the take, make, and dispose model to a circular system of reuse, repurpose, and recycling. And just to talk a little bit more about what we mean when we use these terms. So reuse primarily means putting the battery back into its original application, in this case, mobility, as we define it, after some basic testing and small repairs as needed. Um, and repurposing, on the other hand, is the use of a battery in a secondary application, such as stationary storage, after there is some amount of disassembly, reconfiguration, and component level validation that happens. Uh, and lastly, we move on to recycling, where we believe all batteries do end up, where we recover the constituent materials, including lithium, cobalt, nickel, aluminum, etc., through chemical and physical reprocessing of batteries that have reached end of their multiple lives. This shifts import dependence, lowers costs, and creates jobs and reduces environmental impact, alongside lengthening the life and value of a battery. If we can move on to the next slide. So why are we talking about battery circularity in this day and age, right? Because battery demand itself is going to grow 40-fold, as we had sort of discussed earlier. And used batteries will surge from 2030 onwards as EVs that are currently in the market reach their end of their initial life. A few nuances here is that this is assuming energy independence by 2047, so full phase out of crude oil and gas, and an LFP chemistry-led mix. Why this slide is important is because we need to embed circularity practices in our ecosystem in this decade before demand surges, to be able to strategically leverage the opportunity of circularity. Next slide, please. And by 2030, what we're estimating is that 11 gigawatt hours of used EV batteries will be retired. And this volume is expected to grow even more exponentially in the years that follow, which is why planning for circularity is important now. As you will see on the left side of the slide, collection gaps currently remain significant, and we expect them to remain significant in the 2030s itself. So traceability and take back programs are a must to ensure early circularity pathways have sufficient feedstock. Um, and what we mean when we sort of lengthen the life of a battery is that all the gains that come from recycling and all of the circular pathways that we build from recycling still remain. They're just delayed by repurposing so that we can extract the maximum value out of the battery. And as a result, infrastructure must plan for these future peaks and volumes and not just the early stage inflows. Next slide, please. And as a result, if we are able to create the right kind of infrastructure and ecosystem, we expect about 75,000 crores of economic, social, and environmental opportunity, primarily coming out of repurposing, to a certain extent from the recycling market as well. And as we go forward in this journey, we expect more jobs, more economic activity, lesser emissions, better land use and water use. This graph, just as a clarification, represents the net present value of this opportunity from 2025 to 2050, and monetized values of the margins coming out of social and environmental value as well. Next slide, please. And now coming down to the four levers that we'd spoken about earlier. Policy levers are needed to advance this particular opportunity capture, and they need to go beyond just compliance. So for example, as we look towards the entire battery value chain from cell manufacturing to reuse, repurpose, and recycling, we need to embed circularity in battery design standards. We need to stipulate that OEMs must provide secure access to cell level data and BMS for reprogramming capabilities. Then as we think about EPR, which is a great starting fundamental for battery waste management, we need to prioritize reuse and repurposing before recycling, and then define what end of life means truly based on the state of health and remaining useful life of batteries. In addition to that, we need to focus on certification standards for second life batteries. And as we come to sort of black mass, we need to regulate the export of black mass to be able to capture value domestically. And we need to have formal end user disposal obligation as well. And then as we sort of talk about how this ecosystem kind of grows in and of itself, we need interministerial circular battery task force, where we all the stakeholders, including MOE, FCC, MHI, MNRE, Ministry of Power, and BIS, align on definitions, standards, and compliance. And then we can also look towards mandating recycled content in public procurement as well. Lots of variables to focus on here. And as we move on to the other pillar, let's talk about traceability, right? Here, we refer to traceability as the ability to track a battery and its materials throughout their entire life cycle, from where the minerals are extracted to where performance is in its initial life and then its extended life as well. So just for context, once a battery exits its initial first life, traceability systems must enable secure and informed routing on whether we need to reuse the battery, repurpose the battery, or send it directly to recycling. And what you'll see in the flowchart is across all of these pathways where we see opportunities for traceability infrastructure to crop up. As an example, if we talk about battery reaching the end of its first life, we can develop a traceability similar to what we are currently defining as a battery Aadhaar, which confirms origin, ownership, chain, and compliance. Whereas if we move on to secondary usages within reuse and repurposing, real-time state of health data, warranty records, ownership validation, and reuse records itself become much more important. And as we talk to move away from the reuse repurposing chain towards recycling, um, end of life flags where the battery is ready for recycling need to be marked clearly, and recycling compliance certificates need to be generated as well. If we can move on to the next slide. Let's talk about financing, right? So, there is a massive opportunity to fund this infrastructure, but also we need fit for purpose financial tools across this value chain. So we need about 175 billion by the year 2050 to be invested across this value chain. However, each stage requires some tailored financial tools. For example, material refining and cell production need more large scale equity, viability gap funding, and PPPs, given the scale of the investment required. Whereas recycling and repurposing are better suited for instruments like concessional loans, credit guarantees, and ESG aligned equity, especially for MSMEs and startups that grow in this space. Next slide, please. Lastly, talking about technology development and workforce development. Technology development is focused here to drive foundational innovation and indigenous manufacturing capabilities. Additionally, workforce development is needed to support livelihoods, inclusion, and safety. So, for example, within technology, we need to focus on design for circularity and how to create more second life applications, as well as how to maximize end of life recovery. And at the same time, workforce development is required to be able to ensure safety and higher handling standards, as well as to maximize jobs as well. If we can move on to the next slide, Tanishka. All of this kind of culminates into a platform to advance circularity and for technological development, and which is where RMI is going to be focusing on going forward, where we want networking and collaboration, where we bring together policymakers, industries, financiers, and innovators to accelerate the battery transition. We want to share learnings from regional stakeholders and build technical, financial, and policy expertise. At the same time, we want to focus on capacity development of startups and organizations in the space, on how to build better pathways for reuse, repurpose, and recycling, and alongside doing some techno-economic and policy analysis, and sharing global learnings which are tailored to India. Deploying circular economy and recycling initiatives is also a key part of this platform, where we focus on launching and supporting on-ground initiatives from financing to creating a sort of network uh, where ecosystem players can come together, and everybody who's sort of a relevant stakeholder in this entire platform and initiative should be hearing from us very soon, as we work on finalizing government partnerships and sort of a more structured approach to this platform. But that's a bit of the context to what the panel discussion will be about. And back to you, Weber.
Thanks, Akshat. With that context in place, we're excited to now turn to our panel of industry leaders who are at the forefront of shaping India's battery circularity landscape. So please join me in welcoming Mr. Arvind, founder, director, and CTO of MiniMines. With a background in nanotechnology and deep experience across energy storage and material science, Arvind leads the R&D and technology development for sustainable lithium-ion battery recycling and circular clean tech solutions at MiniMines. We're also joined by Mr. Darshan, co-founder of Nunam Technologies, where they focus on building financially viable second life battery solutions through a unified platform that streamlines and optimizes the battery lifecycle. Thanks for joining us, Darshan. Next, we have Ms. Pramodha, Program Manager at the Global Battery Alliance. Pramodha leads the Battery Circularity Program and supports the Battery Passport Initiative at Global Battery Alliance. She brings over 15 years of experience in electric mobility and sustainable transport planning. Welcome, Pramodha. Also, we have with us Ms. Praniti, Head of Public Affairs at Loham, an integrated lithium-ion battery manufacturer and a recycler with an aim to reduce economic and environmental costs of electrification. Thanks for joining us, Praniti. We're pleased to have Mr. Suraj as well, Head of Battery Engineering at Aether Energy. Suraj leads the development of Aether's next generation of battery systems. Welcome, Suraj. And finally, moderating today's conversation is my colleague, Ms. Samita Shiladhar, Director of RMI's Global Transportation Practice. Samita leads RMI's efforts to advance clean, efficient, and affordable mobility solutions across India and global south. Welcome, Samita. And without further delay, over to you as well.
Thank you so much. And first of all, thank you so much to all of the panelists for joining us today and all of the audience for being here with us. We've just heard about why battery circularity is such a critical topic, and the goal of this session is going to be really unpacking what exactly circularity means in practice and how can we build a system that is scalable and globally competitive. So without further ado, let's start with the panel discussion. We'll start with a few broad questions and then move into specifics, and we'll close with rapid fire. As my colleague already mentioned, just a quick note for all the audience, we have a Q&A as well as chat box open. So if you have any questions for any of the panelists, please feel free to put those and we'll cover those towards the end or weave those during the discussion. So to kick off our discussion, I would like to pose an opening question to all of our panelists and get all of your views. As already mentioned by Akshat, as EV adoption is taking off in India, the battery demand is projected to grow nearly 40 times, with EVs making up to about 80% of the battery demand. And this gives us a critical window right now that before the demand surges, we can still embed circularity into the battery value chain. So, to begin our discussion, I'd love to hear all of your views in terms of where do you see the momentum building in the entire battery circularity space, and how exactly does your organization see circularity strengthening and shaping the broad value chain? We'll start with Mr. Suraj.
Hey, okay. So, especially in terms of circularity, I think what I'm really happy about is to see how India has progressed in the last 2-3 years. Started off with BWMR, which is the battery waste management rules, which came into effect about 2 years ago, which led to an entire ecosystem of recyclers, establishing themselves in India and also setting up operations. I think now we have 8 to 9 major recyclers, as well as we have and these are operational, right? And there are a bunch of others which are still in progress. So yeah, that gives me a lot of joy seeing the progress.
Thank you so much for sharing that. Praniti, do you want to go next?
Sure. Thank you, Samita, and thank you to the entire RMI team for organizing such a wonderful webinar panel discussion here today. I think I'd like to echo what Suraj mentioned. I think a lot has been achieved in India in the last 3-4 years. I think there is a lot more work that needs to be done, but I think the government is giving the right levers to the industry to kind of take off. I think, like Suraj mentioned, the battery waste management rules, extended producer responsibility, these are all mechanisms and tools and system design shifts that will help India achieve its circularity goals. I think specifically one thing that I think producers as well as recyclers are looking forward to is, further guidelines on the composition of recycled material that will be required in batteries starting 27, 28, according to the battery waste management rules. So that's something that we're looking forward to. But I think just kind of going back to the basics, there are, still a few things that present themselves as challenges in the sector. So the first one is definitely the level of formalization within the sector. I think the level of informal participation in this sector remains relatively high. More than 90% of the collection currently happens informally. More than 70% of the recycling is also happening informally. And this is obviously, problematic for a whole bunch of reasons. First of all, these are hazardous materials that should not be in the environment, that should not be handled by people who are not wearing the right protective gear, that don't have the right skill set, that don't have the right technical capabilities to process this material. And secondly, also because of the loss of economic value that informal processing of these of this scrap material presents. There's critical minerals, lithium, cobalt, nickel, that we are losing out on because of the informal sector. So I think this is definitely one of the biggest challenges that we see at Loham. One of the ways in which we see this can be resolved is a reduction of GST on battery scrap from 18% to 5%. We believe that this will bring a lot more players into the formal fold and potentially lead to greater recycling in the formal sector itself. The second thing I think, the RMI team has already covered at length as well is traceability in the value chain. I think programs such as the Battery Aadhaar definitely show a lot of promise. We've seen this in Europe as well, with the battery passport system. We're looking forward to, the offtake of this through DST and other government agencies, along with support from industry players such as Loham and Tata, as well as others. So we're optimistic on Battery Aadhaar, and we feel that measuring these metrics early on in the life cycle of the battery will become extremely important in ensuring that it is able to contribute value even in second life. And yeah, I think I'll stick to those for now, but looking forward to the rest of the discussion.
Thank you so much for sharing that. Mr. Arvind, would you like to go next?
Thank you so much, Shamita. I guess all of the points which I wanted to speak is already covered by Praniti actually. So, but there are still like a couple of gaps, as she mentioned, so it's a leaky bucket, I would say. First of all, the collection mechanism, we need something which can strengthen the traceability, or which is Battery Aadhaar is going to put up that kind of solution in that. Second thing is processing capacity. So government is actually helping startups and companies to give some kind of OPEX and CAPEX subsidies and all those things to increase the processing capacity, and which we can actually cope up the requiring coming demand for that. And then APR implementation is already there, but still requires some kind of strengths and strengthening the traceability in that also. And the government is also working on setting up the benchmark for the recycling capabilities as well as recycling mechanism. So must be some kind there is a requirement of standardization in all the parameters of the recycling as well. And most important thing is there must be some kind of integrity in terms of recycling processes as well. So battery recycling just started, and this can also actually help in increasing the umbrella in other materials as well, like permanent magnets. Then we have a lot of waste which is going to come up in next 10 years from your solar industries as well. So this is overall a good approach, but it requires a lot of solutions.
No, thank you so much for sharing your perspective. Mr. Darshan, over to you.
Thanks, Arvind, Praniti, and Sumit, for having set the context. From a repurposing point of view, I think the RMI team has identified the key gaps in the market to scale repurposing. That is access to the hardware, and as well as ensuring that there is data transparency in the ecosystem. I think the only thing I would like to point out or highlight is that if we as an ecosystem would like to implement circularity in full force, we need to go by the principle of circularity of first being able to repurpose. Yes, if there is no techno-commercial fit possible to repurpose, and then definitely recycle. This should also bring some alignment in terms of how do you incentivize the end customer to bring it to the formal market, which in turn will streamline the entire ecosystem, because if the gray market is able to pay more at the leaky bucket scenarios, so the material will still go away. So we need to ensure that the economic incentives are aligned to the end customer and the companies to bring in circularity in true sense. Thereby, you try and first fix the battery if there are some issues, if from an EV perspective. If not, repurpose it to ESS. If not, you then move to recycling. So we must go through this phase to make most of every battery that is produced in India, and both it's a win-win for both in terms of environment and the economics around the value chain.
Yeah, thank you. Thank you so much for sharing that. Pramodha, over to you.
Thanks, Samhita. Just a little quick note about the Global Battery Alliance, something maybe not all of you are aware of. Global Battery Alliance is the world's largest pre-competitive alliance for public-private collaboration to make battery supply chains responsible, circular, and sustainable. We've been working on a set of benchmarks for the battery to evaluate it against, and so that it lays the foundation of certification of batteries. And next week at Climate Week, we are launching a beta release of this benchmarking framework, which looks at sustainable sourcing, circularity, technical parameters of the batteries. So with that perspective, I'd like to bring in what's happening across the globe to this conversation, and supplement the other technical folks from India who are working on these challenges. So worldwide, there is a lot of apprehension about supply chain resilience due to a lot of shortages, disruption in geopolitics, changing trade barriers, and the heavy reliance on virgin materials. Now, we view at the Global Battery Alliance that circularity is the key measure that we have to decrease the need for these virgin materials, increase all regions' mineral supply gaps, increase the resilience, improve national security risks, and as well as reduce the harms associated with mining. While doing this, we can also increase access to clean energy, accelerate EV and clean mobility applications as well. So this is one of our foundational pillars for our organization, and we are doing that through the lens of battery traceability systems through the Battery Passport program. So I'll stop with that, Samhita.
No, thank you. Thank you so much for sharing that. And I think all of your thoughts really kind of set context even more in terms of different elements of battery circularity, starting from including everything from reuse, repurpose, as well as recycle. I want to ask follow-up questions to all of you based on some of the answers that you had shared. So my first question is for Mr. Suraj. I think in terms of your role as well with Aether, you've mentioned that the circularity is not just happening at the end of the life, but it also begins at the design stage, and that is like one of the core elements of Aether, and OEMs have a critical role in terms of shaping how exactly batteries can be reused, repurposed, or recycled. So my question to you is, what design approaches are you pursuing to enable this circularity, and how is it tying to Aether's long-term growth strategy?
Okay, Samhita, great question. So, see, one thing we've done at Aether from very early on is we've had a very stringent focus on quality. And what that has meant is we put our batteries into very extensive testing. So after these tests are done, the batteries are available. Not all batteries are at the end of life after a test is completed. So it was an internal exercise wherein we said, okay, we have all of these tested batteries. How can I repurpose it for another test, or how can I maybe run a few test ride vehicles with it, or figure out any other internal uses for these batteries, right? So that's where our question on circularity started back in 2018, 2019. And that has brought in a focus on having circular designs from the grounds up. Um, like Darshan mentioned, the priority is always reuse, repurpose, and only then recycle. So the first priority for us is how do we reuse most of the parts that go into the battery pack, right? So a battery pack has cells and has a lot of other materials along with the cells, right? It has your cell interconnects, it has the BMS, it has a bunch of bus bars, harnesses, thermal sensors, vents, and obviously the external structural like enclosure. So our first question we asked ourselves is, okay, how do we reuse all of the parts which are apart from the cells, assuming the cells are not fit for repurposing or for recycling, right? So that's the first thing we do, and we do that even today on most of our batteries. Is if we ever have a battery that has completed a test or has come back from the field because of its end of life, although those cases are handful, but whatever comes, the first thing we do is we reuse a lot of the components inside the battery pack, and we either put that into a new pack or we put that into an internally used pack. The second thing that we try to do is figure out how we can repurpose the entire cell matrix, right? So we've all the latest models of Aether batteries in the past about a year or so have a modular architecture, so we can completely remove the entire cell stack and then put it into any other sort of an application, right? So that's kind of what we are moving towards. The focus on circularity, one obviously is from an environment perspective, but also very selfishly looking at it for the company, it is an economics perspective as well, right? The more you can reuse, the lesser your losses are going to.
Thank you. Thank you so much for sharing that. And just picking up on that, I have a next question for Mr. Darshan. So we already heard from Mr. Suraj that the circularity is more than just recycling, and it is really important to get maximum value out of a battery through reuse and repurpose before sending them for recycling. I wanted to get your opinion on why do you think India is especially well positioned to enable effective secondary use of batteries, and any of your thoughts to support or on the topic of what Mr. Suraj has already shared.
See, I think as a fundamental uh, concept, we all know that the blur between mobility and clean energy is almost going away because battery is becoming the central focus point, right? So the good part in India is on both these fronts, you have a good variety from two-wheelers to electric buses in mobility, variety in terms of the battery sizes, configurations, etc. On the other side, from a downstream energy consumer for grid or grid allied purposes, again, you have customers who can consume a lot of variety of batteries. So it's extremely important that this demand and supply gets aligned. And in some countries, maybe it is not aligned that well because there is a certain category of customers only. But in India and in the near neighborhood, we have this full variety, a full spectrum of consumers, and a full spectrum of battery packs coming out. So that way, there is a good chance that as a country, as an ecosystem, we should be able to pipe this end of life EV to a consumer who can use this safely for a couple of years before end of life is reached. But yeah, all the levers required for this has to be put in place for this to happen.
All right. No, thank you. Thank you so much for sharing that. My next question is for Praniti. So, as Loham is working across the full kind of full chain from all the way up to refining, I wanted to get your thoughts on the scaling part of things. So, industrial scaling of recycling and refining will be really central to making sure that India is successful on the entire battery circularity journey. So how do you see this scaling up, and what will it take for recovered materials to, re-enter India's supply chain at a true battery grade quality?
Sure, thanks, Samita. Yeah, I think you're right. Loham really does cover the entire value chain, and that's been our play for the last couple of years now as well, and moving forward, of course. So we are into recycling, we are into processing of critical minerals. We are also into manufacturing now, with cathode active materials as well as permanent magnets. So we really see ourselves as value chain players, and keeping in mind that we really see the levers across three primary verticals, so demand, supply, and technology or capability development domestically. So I think I'll speak a little bit about demand first. So as far as demand is concerned, what become really, really important for India is the downstream industries such as pre-cathode active materials and cathode active material manufacturing domestically. In this segment, it becomes particularly important to compete with China. Currently there are export controls. China has banned the export of all latest LFP technology. And imposition of basic custom duties on finished products will also prevent dumping from China into the Indian market and kind of development of the domestic ecosystem. For this development, what also becomes really, really important is government incentives in the form of production-linked incentives for specific components such as CAM. So I think once the downstream industry comes to fruition, the demand piece of the puzzle can be solved better. The second piece is, of course, supply. We've spoken about this a little bit in the first question as well. Waste collection, formal recycling is, of course, a big challenge. So that's where a lot of your supply for critical minerals gets hindered when you don't have access to the right amount of feedstock domestically. We obviously see feedstock increasing substantially in India, as was highlighted in the statistics the RMI team shared as well. But in order to capture the true value of this feedstock, it'll become important for formal recycling and formal collection to happen. And that's where we look at, government agencies such as MOEFCC and CPCB to implement the right collection, handling, storage guidelines, which is already in the works. Secondly, on the supply piece, we also believe that it becomes important to work with international partners on this. So both the US and EU present as very valuable sources for feedstock, for, of course, automotive, but also for electronic waste. In fact, according to some of our estimates, the feedstock availability in the EU is approximately 5 times the availability that in India, just because of, the scale of maturity of the industry over there. Their electrification journey started a little before ours, and end of life more. Europe also represents 30 to 40% of global battery scrap availability, excluding China. So that's definitely a market that we don't want to miss out on. Currently, we're missing out on it because they have banned the export of battery scrap and black mass and other materials. They've deemed it as hazardous, which means they can't go to non-OECD countries such as India. So, inclusion of these aspects in the ongoing free trade negotiations, free trade FTA negotiations would benefit the recycling industry and would bring it to scale. It'll allow the industry to kind of develop with the right amount of feedstock, with right amount of capacity utilization. And we believe it's advantageous for even Western nations such as Europe and the US because of the processing capabilities that exist within India, as well as the low costs that exist within India. Recycling within India is approximately 1/3 to 1/5 the cost of that in Europe. So it's kind of a win-win situation for everyone. And then the last pillar is capabilities and technology. So the way we like to think of it within Loham is, developing technologies across the technology readiness level scale. So not just looking at particular pieces, but looking at the entire spectrum from TRL 1 to TRL 9. Again, in order to enable this ecosystem domestically, it'll become very important to for the government to step in for nascent technologies which are in TRL 1 to 3, where they're at the academia or R&D lab level. Government grants become really, really important to truly test the technical potential of a technology and whether it's a viable solution for the domestic industry or not. Then you look at TRL 4 to 8, which is where more market offtake, more product market fit, those kind of things come in. That's where equity investment from the government can be beneficial, where the government can also get buy-in into the technology that'll, potentially be taking the nation to the next level. And then comes TRL 9, which is again industrial scale commercialization. So that for that, I think again production linked incentives become really, really important. We've seen the government really double down on R&D and technology development domestically in the recent past. There are mechanisms such as the ANRF fund, which is, a sizable amount, about 1 lakh crore rupees. So we see all of these indications from the government is extremely, extremely positive. And we hope that they will help the domestic industry flourish. But again, there is so much to be done. So, no amount is really enough. But yeah, those are the three verticals on how we think about industrial scale for recycling and processing capabilities in India for critical.
Got it. No, thank you so much, Pranati, for sharing that. And my next question for Mr. Arvind is actually kind of building upon this. As Pranati mentioned, there are several kind of government incentives or government signals that are really sharing, like a strong support towards critical mineral recycling. For example, the National Critical Minerals Mission or Cabinet's recent announcement with respect to the scheme. So my question to you is, what opportunity in battery and critical mineral recycling do you find most exciting, and what other systemic change, be it policies or market incentives, do you think are going to be most critical in order to make large-scale lithium-ion battery recycling more viable in India?
Yeah. So the most exciting opportunity in battery recycling or critical mineral recycling is creating a domestic supply for these minerals like lithium, cobalt, nickel, and manganese. But and going forward, as your slide also shows that most of the part is going to shift towards LFP based chemistry. Lithium is going to be the most important mineral in that. And by 2030, India is targeting over 80 million EVs, and Indian roads also are supporting that. Government is also supporting that kind of scenario, and recovering 95 to like 98% of critical mineral through that through the technology which we are developing in-house in advanced hydrometallurgical technologies, then direct recycling also. All those technologies going to significantly reduce the dependence or the imports and build resilience in our clean energy transition. And also beyond EV, stationary storage for renewable energy, consumer electronics, all those things are also being supported by recycling industry and spent batteries. Uh, this creates a room for innovation in second life applications as well, and a lot of people are working. Darshan here is quite good in that. And batteries with 70 to 80% of SOH, which we are right now considering as a second life application based batteries, is going to create a huge demand or market demand in the grid balancing or backup power supply. However, scaling this vision requires a systematic change. The first thing is clearing the EPR policies, because right now there are a lot of places where we need some kind of fixes in that, in terms of supply chain, formalizing the market, second life market also. And then second, the market incentive also are required, like tax benefits, like GST, as Pranati mentioned. We need to change from 80% to 18% to 5%. That will actually help a lot of players in this ecosystem. And then the most important thing is which comes from the OEM and the battery pack manufacturer, is the design to dismantle or design to recycle. That is the most important thing, because right now the design for batteries are completely different for all the OEMs, and it makes a lot of thing. It makes things complex for every dismantler or recycler to open up a battery pack which is coming from different OEM. So it makes them the dismantling manual, and reduces the capabilities in terms of capacities and then efficiency as well. So there are a couple of things which we need to work upon. Thank you.
Thank you so much for sharing that. And I'm also seeing a lot of questions in the chat and Q&A box, so I want to get to those. But before that, I have a question for Pramoda. Since Global Battery Alliance is working, with kind of different parts of the world, globally we are seeing that traceability is really key in terms of enabling circularity, and ideas like battery passport or battery Aadhaar, as it was mentioned before, are gaining traction. So what do you think would it take for India to build a strong traceability framework, and how would this strengthen the overall battery ecosystem?
Yeah, thanks, Amita. That's a really important question. For India to build a traceability system, I don't think the challenge is, the database or the technological parts of it. It's more about us having clarity on that's our aim to do so. And as in other areas, a carrot and stick approach is required. We shouldn't view it as a compliance burden, but also just as a competitive advantage. And should also view it as a tool for reaching our ambitions in terms of recycled content target requirements and things like that. Now it's a challenge across the world, and India is also going to have to make a lot of investment into capacity building to be able to achieve that. But there is a benefit of doing that, because traceability is not just about compliance. It's about building trust. It is about building trust between the regulators, with public, with the civil society organization. It is about giving a competitive advantage, and it is about enabling circularity. So our view about why traceability, why we need to put it in systems into place should change. And this will unlock the ability to make responsible supply chain decisions, responsible purchasing decisions at the consumer level. And by unlocking information on the data of the battery itself, the state of health, the state of charge, and so on and so forth, we will unlock newer business models that can improve energy energy access, new business models. Right now, everybody is hesitant to share that information outside of their organizations because of lots of hesitancies. But having a global system in which this information is safely shared without impinging upon any specific access or specific technological issues, data, I think that is the key for us, and working with global systems, not in silos, right? Because the global battery supply chain is very, very globalized and also severely concentrated at the same time. So we need to work with global systems. We can't establish something just for India. It has to be interoperable. That is the key word. It has to work with the Chinese system. It has to work with the US. It has to work with the EU. Otherwise, we'll just be working with the EVs in India, with the batteries that are produced in India. So that is the main thing that we need to unlock, is an interoperable system.
Perfect. No, thank you. Thank you so much for sharing that. I have so many follow-up questions, but I'm also seeing a lot of questions in the chat. So I'm going to move on some of those, and then we'll get back to our rapid fire round. One of the questions, and maybe if anyone feel free to answer, but probably I think Mr. Suraj, if you want to begin with this, there are a lot of questions which are about potential for new and innovative battery technologies. Ceramic batteries or solid state batteries, which could have higher energy density or better battery life. So just wanted to get your or anyone else's perspective in terms of where exactly does the innovation stand in terms of improved battery technologies, and what exactly does it mean to have improved battery technology as well.
Sure, I can take that. So, in terms of solid state batteries, yes, it offers higher energy density, but today the technology is not at a place where it is commercially viable yet, right? We've been like there are a couple of companies experimenting with it. QuantumScape, I think Mercedes also ran a project with them where they put it into one of their cars. I think it's very early stage. There are challenges with solid state. There are massive challenges on life. Right now, we see that the cells that are coming off the production line are barely able to manage 500 to 1000 cycles in a very controlled environment, right? These are not real world cycles, but these are just charge discharge cycles on a machine where it is kept in an AC room with a very low power rate, right, for discharge and charge. So I think it will take, at least what I'm hearing from most of the research papers I read and the conferences I attend, is that it's going to take another 3 to 5 years to be commercially viable. And the point at which it becomes commercially viable, the definition of commercial viability is to achieve higher energy density and meet the cycle life requirement of a typical NMC, NCA, or an LFP battery, right? I don't think solid state today is being looked at from the perspective of having very, very high cycle life, and hence might help with circularity, right? I don't think that's going to happen. I can also comment on sodium ion. I think there's a lot of noise around sodium ion as well. Yes, sodium ion is more easily available. It's easier to get sodium and manufacture with sodium than with lithium. However, the energy density with sodium is extremely low, and the cost is also fairly high, right? So if you compare sodium ion with LFP today, we are seeing that sodium ions are at a density that's 30% lower than LFP. And in terms of cost, right now the costs are extremely high, but the projection for cost is that 2 years, 3 years later, it's probably going to be 10% more expensive than LFP, right? This is 3 years later. This is what the projections currently look like, right? So with that, I think the primary focus of sodium ion will become more towards safety rather than cycle life or energy density, right? So sodium ion will go into applications where safety is of utmost importance. And people will pay a premium for that safety even though it is lower in terms of energy density, right? So I think that's what we see today. The challenge for us is going to be how, like you showed in your graph, most of India's fleet, or maybe 60-70% of India's fleet, will consume LFP, right? And today LFP is not economically viable to recycle, right? I will skip the reuse and repurpose because those will just delay the recycling problem. Eventually it has to get recycled, right? So how do you make LFP economically viable to recycle will become the big challenge. And breaking that down further, the biggest lever will be in how efficiently we can extract lithium from these batteries, right? Because the process efficiency for lithium extraction is fairly low today. We are able to economically recycle NMC and NCA batteries because of cobalt, and because cobalt is very expensive, it offsets for all the low process efficiency in the recycling piece. But just focusing on the recycling efficiency of lithium will be the key problem statement if India has to become economically viable and recycle LFP at scale.
No, thank you. Thank you so much for sharing that. I'm going to aggregate a few recycling related questions since many of them are popping up, and maybe Mr. Arvind, you can answer some of these, and then I'll also open it for rest of the floor. A lot of questions are regarding whether the value of critical mineral recovered by recycling justifies the cost, especially with respect to LFP batteries. And since there are many battery chemistries that are in development, what impact does it have in terms of recycling? And if there are any efforts that recyclers are making with respect to, aggregating different kind of batteries from different places. So if you could start, and then I would love to hear anyone else's perspective on this as well.
So I'll begin with the different chemistries which are coming in the future. So as far as we can see is almost it is going to take almost 5 to 6 years to come, and any battery chemistry to come and replace lithium-ion batteries in the majority of the application, mainly EVs. Second thing is people are saying that LFP is not viable, right? So why we say that recycling of LFP is not economically viable is because right now recyclers are paying to the OEMs to get the batteries first of all, right? Whether it is LFP, NMC, LCO, anything. So, and that value is actually a cost for the recycler as well, right? So, and the value which we are paying to a OEM is being decided based on some kind of value, and then there's some kind of payable or discounting factor based on our processing costs. Right now, the LFP cost, the OEMs are expecting that they are also expecting some kind of value out of it, and that they are measuring based on the value they have given to the cell manufacturer or the materials available in the batteries right now. If the recyclers are getting the batteries at a bare minimum cost, then it becomes viable first of all. So
Right.
government is working on setting up a benchmark where they will set up they'll calculate the basic pricing of the processing cost of the battery recycling for all the chemistries, and they are trying to set up a benchmark that this much is the cost of the waste of any kind of chemistries you can charge or any OEM can charge. Then after that, once it comes into picture, then the LFP recycling will also become a viable solution for Indian ecosystem and Indian scenario. And right now, as Pranti also told that our technology or in our Indian technology is capable to actually recycle any battery chemistry at very fair viable cost than any other country like Europe or US. If you see, we are at least 1/5 of the cost, processing cost than these countries and these regions. So it's not uh, it will not be a hard thing to say that in next coming 1 or 2 years, LFP recycling will also become viable at scale. Right now, there is no scale, first of all. Once it comes to a scale, and then OEMs are also understanding what is the market dynamics or what is the true value which they should ask for from a recycler. Once this comes into picture, that will also become a market tendency.
Right. No, thank you so much for sharing that. My next set of questions is for Mr. Darshan and Praniti, both of you, if you could share your thoughts on this. Apart from recycling, in terms of repurpose and reuse, first is how does end of life EV batteries, depending on the end of life of different batteries, what different applications are there with respect to storage, and what is the benefit of an OEM in opting for repurpose versus recycle versus reuse? So Praniti, if you can share, and then Mr. Darshan, if you could also share your thoughts.
Sure, thanks, Amita. So yeah, I think, like you mentioned, I think the users can be plenty across the energy storage, across energy storage systems, and I think a lot of it is going to be determined by the metrics that you evaluate when you're conducting the cell R&D. I think in terms of how much of state of charge is left, how many cycles are left, all of those metrics will become extremely important in evaluating what the repurposing or the reuse of the battery can be. I think we do a lot of the diagnostics in-house at Loham as well, to evaluate what next to do with the cell and the battery. And I think having those metrics definitely helps us determine what should be done with the battery or the cell itself. So yeah, I think standardization across those metrics, what should be evaluated, what should be tracked, what should be incorporated in a system such as Battery Aadhaar will become really, really important as well.
Mr. Darshan, any of your thoughts on this?
See, the end user is part of let's say, in a standard energy market. He is looking for an energy solution that may be from anywhere from DG to news, the cell-based backup systems. So for us, repurposing repurposing products, yes, obviously we want to replace those DGs. And any other customer who is able to extract at least 5 years of life from these second life batteries is our customer. So it could be any from a small office backup to a small industrial backup solution, and microgrids and other use cases. Wherever you have lead acid not being able to conform to the end customer's needs. So that is when people start looking at lithium-ion batteries, and it's the same market. I stress on it multiple times that there is no specific repurposing battery market. It's the same energy market, and we have to compete with other products to gain the customer confidence.
No, thank you so much for sharing that. My last quick question that I'm going to take from audience, I know we are already a minute over. Pramoda, if you could just share any insights in terms of how could traceability address the issue of fake EPRs? I think that's an important one. If you could just share any of your thoughts on it.
I think the system needs to be set up in such a way that doesn't happen. And while you're setting up that system, if you're thinking of interoperability and verification and credibility as the cornerstones of setting up that system, I don't think that's an issue. So there is certainly, QR-based and blockchain-based solutions, and that is essentially what a tracking and traceability system is, that it can be trusted and verifiable. So I don't have operational answers for you, but that becomes a design principle which will ensure that they can't be faked.
Perfect. No, thank you so much. I wish I had more time for rapid fire, but My one last rapid fire question to all of you is, in one word, if you could describe the future of battery circularity in India, and we'll end on that note. So I'll start with Mr. Suraj. Just one word, how would you describe the future of battery circularity in India?
For me, that word is agile. I think we have to adapt to geopolitical stuff as well as economies of scale within the country. So we definitely have to be agile on it.
Thank you. Mr. Arvind? You're on mute.
Yeah, sorry. So I would say the collaboration part in between the recycler, the second life battery pack manufacturers, and then OEMs. The collaboration should be there, and that collaboration will actually derive the market of designing and the chemistry and recycling part of it, and then better traceability.
Thank you. Ms. Pranti?
I'm going to be a little optimistic and just say possible. I think it's quite possible with all of the efforts being put in by the panelists and the different industry representatives here today, as well as by the government. I think we're in a good position, so I think it's possible.
Thank you. Mr. Darshan?
I would steal the word from Suraj. I think agile is the right word. We have to just move fast.
Thank you. And Pramoda?
I would say it needs to be multi-stakeholder and pre-competitive. Those would be my guiding words.
No, thank you so much. It's been real pleasure speaking with you all today. I wish I had much more time. I'm sure even audience feels that way considering how many questions we have gotten. But it's been real pleasure speaking with you all today. Thank you so much for our incredible panelists, for your thoughtful insights. Thank you to Niti Aayog and my colleagues at RMI for putting this webinar together. And thank you to all of the participants and audience for engaging with us today. Wishing everyone a wonderful day ahead. Have a good day. Thank you.
Thank you.
Thank you, Samhita.
Thank you.
Thank you.